Hi, welcome to my channel EasyML. In the previous set of videos, we looked at the theory behind exploratory data analysis. In this video, we will deploy the concepts of data exploration on the iris dataset. Recall that data exploration had three stages, namely data summarization, data visualization, and finally data normalization. We will examine each of these stages with the help of the iris dataset. We will now go to the scripting window, which is the top left quadrant. First, let us install the relevant packages that are a prerequisite to exploratory data analysis. I will use the install.packages function for that. So, install.packages stats install.packages dplyr, and then so here we have two packages. One is the stats package and the other one is the dplyr package. The stats package has functions that can help with data exploration, and the dplyr package has functions that will help with data manipulation. Note that I will not be running these lines of code since I have already installed these packages. Now let us move on to the library function, or rather the usage of the library function. The library function will help invoke the contents of a particular package. Now, let us use the library function to access the contents of the stats and the dplyr package. So, library stats and then library dplyr, and then I'm just going to quickly select and run. Well, now the libraries from both these packages have been successfully loaded. Now, if you can recall, I had mentioned that we will be using the iris dataset. So it is important for you to note that the iris dataset is already preloaded in R. It is a default dataset. So in the console, if I type iris here and then just click enter, well, you can see that the dataset automatically appears, right? So it is already preloaded and available in R. So now let us say I want to clear the console or clear the contents of this console. I will use the keyboard shortcut Control L, as in L for lambda. Now let me use Control L now. Control L. Well, now you can see that the console is cleared. Now let us go ahead and load the iris dataset into an object called myData. So I'm going to say myData is equal to iris and then Control Enter. Well, here now you can see that the dataset called myData, the object called myData is now created. It has 150 observations and 5 variables. Now, and you can see that the myData object is also updated in the environment tab, which is the top right quadrant. Now let us use the str function to evaluate the structure of myData. So let me just use str on myData and then Control Enter. Well, here you can see that there are 5 variables. The first 4 variables, that is sepal length, sepal width, petal length and petal width, are numeric in nature. That is what NUM here stands for. Whereas the 5th variable, that is species, well, that has the data type of a factor, and factor is just R's way of calling a variable as a categorical variable. Now let us move on to the first topic in data exploration, that is summarization. Recall that in summarization we first looked at central tendencies. Before calculating central tendencies, I need a sample numeric variable to calculate central tendencies and the various measures of variability. So I will select sepal length from the myData object. Now I will go ahead and select sepal length from the myData object and store it in another object called SL. Now SL stands for sepal length. So let me go ahead and create SL is equal to, then so I'll just go here myData, and then I'm going to use the $sign. Recall, the $sign helps inspect the contents of a particular object. So when I did my data and I press $, I have all the variables that are available in my data. So out of all these variables, I will be selecting sepal length, right? And then I'll just press Control Enter. Now you can see that the object sepal length has been created and updated in the Environment tab. Now let us start calculating the various measures of central tendencies. The first measure is mean. So I will calculate the mean of the sepal length by simply using the mean function. It is as simple as that. So I'll say mean SL and then Control Enter. Well, here in the console, you can see that the mean sepal length in the iris dataset is approximately 5.8 centimeters. Now let us move on to the second measure of central tendency, that is median. For that, again, I will simply use the median function. Median of SL and then Control Enter. Here you can see that the median also happens to be 5.8 centimeters. Now, when it comes to mode, that is the third measure of central tendency, there is no default function available in R to calculate mode. So I googled and got a function for mode, which is right here in the mode function tab. So what I'm going to do is I'm just going to select this and run. Now that I've executed this function, in the Environment tab, under the Functions section, you can see that the mode function is now created. Now let us go ahead and use the mode function on the object SL, that is sepal length. So I'm just going to go ahead and use it here. So MODE SL and then Control Enter. Well, here you can see that the mode sepal length is 5 centimeters. Now, as I explained previously, summarization does not just stop at central tendencies. We also need to look at the various measures of variability for sepal length now. First, let us go ahead and calculate the standard deviation for the object SL, that is sepal length. I will deploy the SD function to calculate standard deviation. So first we'll go ahead and calculate standard deviation SD of sepal length and then Control Enter. Now you can see here in the console that the standard deviation of sepal length here happens to be around 0.82 centimeters. Now let us go ahead and calculate the variance. If you can recall, the variance is just the square of the standard deviation. We will use the var function to derive the variance. So I'm just going to say var, VAR, SL and then Control Enter. Here you can see that the variance is around 0.68. Now let us go ahead and calculate the interquartile range. To calculate the interquartile range, we have a function called the Quantile Function. So I'll just go ahead and call the Quantile Function on the object SL, that is sepal length. SL and then Control Enter. Now here in the console you can see that we have 5 numbers or 5 values that have appeared. So the first value is the minimum value at 0%. The second value is quartile 1 at 25%. The third value is quartile 2 or the median value, hence it is at 50%. The fourth value is at 75% and this is quartile 3, and the last value is obviously the maximum value at 100%. So this is how the whole sepal length has been divided into quartiles with the length of 25% each. So now this brings us to the end of summarization. Now let us move on to the next concept, that is visualization. Recall that the type of visualization we choose is heavily dependent on the data type. That is, we deploy histograms for numeric variables and bar plots for categorical variables. Let us quickly use the str or the structure function again to look at the data types. So I'm just going to go ahead here, str on my data and then Control Enter. Well, here we can see that we have already taken sepal length as an example for numeric variables. Now, as an example for categorical variables, we will load the data species into an object called species. So let me go ahead and create this object called species. So species is equal to, from my data, I'm selecting the only categorical variable. So I'm going to use the $sign to inspect the contents of my data. Here you can see I have sepal length, sepal width, petal length, petal length. I'm going to select species. I'm going to select this, and I've loaded this in an object called species. So as an example for numeric variable, we have sepal length, and we have loaded it in an object called SL. And an example for categorical variable, we have species, and we are loading it in an object called species. Let me quickly control enter. Now, just let me select this and run it. Now you can see that the species object has been created. It has also been updated in the environment tab. As I had mentioned, to visualize numerical variables, we use the histogram. Here, we will deploy the hist function on the SL object, that is sepal length. So let me go ahead and say hist SL and then control enter. Now, on the bottom right quadrant, we can see the output, that is the histogram. Here you can see that we have sepal length on the x-axis and the frequency of observations on the y-axis. If you observe carefully, the bin width is 0.5 centimeters, that is 4 to 4.5 centimeters, 4.5 to 5 centimeters, 5 to 5.5 centimeters, and so on. If you also observe carefully, you can see that the majority of observations have sepal length between 5.5 to 6.5 centimeters. Now let us go ahead and plot the bar graph to visualize categorical data, which is species in this case. So now, before plotting the bar graph on the species object, we need to create a table. So I will use a table function to create a table on the species object. So table species and then control enter. Let us inspect the output of the table function in the console here. Here you can see that the output has the frequency or the number of observations across 3 different flower species, that is setosa, versicolor and virginica. Here you can see that all the 3 flower species have the same number of observations, that is 50. Now I will use the bar plot function to plot the bar graph on this table. So let me go ahead and say bar plot, and then I am plotting the bar graph on the above table. So table of species, right? And then control enter. Well, again on the bottom right quadrant, I can see the output. Here we have species on the x-axis and the frequency of these species on the y-axis. Since all the species have the same number of observations, that is 50, we can see that the height of the bars are same. Now, let us move on to the last topic of data exploration, that is normalization. Recall, we normalize the variables in a particular data set by calculating a measure called the z-score. Now let me use the str function to inspect the data again. So let me go ahead and quickly say str, I use my data and then control enter. Here I have 5 variables. I only need the numeric data to calculate the z-score. The first 4 columns, that is sepal length, sepal width, petal length and petal width, are numeric. As you can see, the data type NUM here. So, and the 5th column being species is a factor, hence it's a categorical variable. I only need, as I said before, I only need the numeric data to calculate the z-score. So I have to drop the 5th column species. So now I will go ahead and create an object called myDataNumeric, and I will use the select function to only select the first 4 numeric columns. So I'll go ahead and say myDataNumeric. I'm only going to store all the numeric variables. So I will select from my data. What am I selecting? The first 4 columns. So 1, 2, 3, 4. I'm dropping the 5th variable species since it is a categorical variable. And I'll execute this, control enter. Now you can see that the my data numeric object is now successfully created, and you can see in the environment tab that it has 150 observations and 4 variables, since the fifth variable species has been dropped. Now let us move on to the z-score calculation. I will use a function called the scale function to calculate z-scores, and I will store the output in an object called z-score my data. So I will just say z-score of my data is equal to, I'm using the scale function on the numeric data that we have just derived from the previous step, and control enter. Now you can see that the object z-score my data has been successfully created, and it is reflected in the environment tab as well. Now let us go ahead and see the z-scores using a function called the view function. So I'm going to see here view z-score my data and then control enter. Now you see that z-score my data has appeared as a tab here. Here we can see the z-scores of sepal length, sepal width, petal length and petal width. Actually, I must explain that here in this case there is actually no need to calculate z-score because all the variables are on the same scale, that is centimeters. But I just wanted to introduce you to the usage of the scale function. This brings us to the end of data exploration in R. In the next video, we will delve into supervised learning. Thank you and stay tuned.